But ultimately, it's all about a conservation of momentum. Now, what is truly exciting now is some of the new technologies we have going into our modern day satellites, ion propulsion. So we're actually using and creating ions. So what we have in this diagram below is we have the rear to the right and the front to the left. And at the rear of the rocket engine are two plates, a negative plate and a positive plate. So they have a positive charge and a negative charge. And the negative charge and the positive charge can oscillate. They can flip back and forth. And for those of you who may have heard about or learned about maglev trains in your younger years, the track is made of magnets which switch their polarity north and south. And so in the same sense, these two plates can switch their positive and negative polarities, which will have the ability to accelerate particles. So moving backward from the opening, we have these rings. Now this is a cross-section of it, so these rings are circular rings. They're circular magnets that go around the entire rocket chamber. Now it turns out, and we'll learn about this for those of you in an AP course would learn about it in a separate course or in college, and those in regular physics would learn about it later in the second half of the year. But a magnetic field caused by a magnet will cause charged particles to accelerate. And so these magnets, like a maglev, there are 3 of them here, or there could be any number of them, can also reverse their polarity. So what ends up happening is when we have ions inside, the magnets will cause those particles to accelerate. Well, when we think about this as a system, we know for every action there's an equal and opposite reaction. If the magnet causes the particles, the ions, to accelerate, the ions will cause the magnets to accelerate. So as we proceed up toward the front of the rocket engine, you'll see there are positive ions, negative ions, and then there's some neutral ions in green. And as we continue to make our way forward, there are increasing numbers of negative ions, and eventually we get to only negative ions and neutral ions, and that takes us to the front. So what is happening at the front is we have neutral ions, or neutral atoms, excuse me, being released into the chamber. Well, if they experience a change in velocity in this direction, that means their release would cause the rocket to accelerate in that direction. So just propelling these outward, this is like the mouth of a balloon or a propellant rocket going on, just those particles. But that's not the primary origin of the thrust. So they are neutral particles, and there's an electron gun that shoots electrons out. Now keep in mind that electrons have 1/2000th the mass of a proton or a neutron. And so these are actually atoms. They might be heavy atoms that have tens of nucleons in them. So it might be like 1 to 20,000. So the mass that's involved in this is largely about the atoms being produced and the positive ions, not so much about the negative ions, because the mass is so small. So in any case, up in the first region of the chamber, we have a magnetic field that's being created, and it causes the negative particles to accelerate. And as they accelerate, they collide with the neutral atoms, producing both positive and additional negative ions. So the negatives were accelerated toward it. And on the other side, now the polarity of the magnet can be switched such that the negative ions and the positive ions will also be accelerated. So the positive ions will be accelerated in this direction, which means that the rocket will be accelerated in the other. And as it's now accelerated to the second magnet, which has an opposite polarity, it's being accelerated not only away from magnet number 1, but toward number 2. And as it gets close and gets very near, the polarity switches again. And so now the positive charge is accelerating toward the magnet 2, which means that there's an additional velocity in this direction, and there's now a change in momentum of the rocket in the other direction. And so what we have occurring at every one of these magnets and interactions between the positive ions and the magnetic fields is an acceleration of the positive ion toward the rear and thus an equal and opposite change in momentum of the rocket, the ion engine toward the left. And that happens multiple times depending on the number of magnets. And now when we get near the end of the rear of the rocket, we have the grid, which is negatively charged. And as the ion gets near, it's of course accelerating toward that positive charge, and the grid is attached to the propulsion. So it is accelerating the engine chamber forward to the left. And as it gets very, very near to that negatively charged grid, it switches polarity, which continues to pull the particle through. And once it's through, it's now positive. It accelerates it away, but the next plate is negative, and so on. And so what we see happening here is by these oscillating, these flipping magnetic and electric fields, we are adding momentum to the positively charged ions, accelerating those backwards, all the while accelerating the rocket engine toward the left in the forward direction. We see this happening multiple times. And you can then see that that would be much more productive than, say, in a rocket chamber up above, where the only interaction is the propellant against the front of the fuel cell. Here we have that happening 2 times for every magnet and 2 times for every plate. So you're getting like 8 times of change, 8 bouts of change in momentum for every particle that's moving along. And so you could, of course, get into this, but this is the future of space travel. Doesn't require us to use fossil fuels and destroy the ozone layer and whatnot. So ion propulsion has, and plus we don't have to carry this humongous mass of propellant. We get much more acceleration for the unit mass than we do with a chemical fuel that we currently use. So ion propulsion is an amazing technology that uses the conservation of momentum. In our next section, we will look at additional examples of momentum and transportation as well as safety.